Hey everyone, in this video we're going to be looking at Chapter 9 of Dive into Python. And before we dive into this chapter, I recommend you have some knowledge of XML. XML stands for Extensible Markup Language and was designed to store and transport data. XML does not do anything. Yes, you heard that correctly. People often say XML is similar to HTML. But please ignore them. In XML, the author defines his own tags, while HTML has predefined tags. HTML was designed to display data with a focus on how data looks, whereas XML was designed to carry data with a focus on what the data is. Example 1 .xml in the folder example 1 shows what a simple XML document looks like. But still, this XML document does not do anything. XML is just information wrapped in tags. Someone must write a program to send, receive, store, or display it. And again, these tags are not predefined. They could be anything like foo, bar, baz, or just something that makes sense to you when you're writing it. When displaying data in HTML, you should not have to edit the HTML file when the data changes. With a few lines of JavaScript code, you can read an XML file and update the data content of any HTML page. Think AJAX calls, if you will. There are generally two ways to work with XML, or in broader terms, to parse data from XML. The first is called SAX, and the second is called DOM. SAX, which stands for Simple API for XML, works by reading the XML a little bit at a time and calling a method for each element it finds. We can say the SAX parser operates element by element and line by line. We will not deal with the SAX parser in this summary, so I'll leave a simple example of how it works. When you run 1.py, your output will look something like this. So 1.py, and that is of course in the repository. I'll have a link in the description as always. But this is basically what that is. When you run this file, you get this result. DOM, the document object model, works by reading the entire XML document at once and creating an internal representation of it using native Python classes linked in a tree structure. The XML package is the package which contains other packages which you will use to parse data from an XML document. Go to the XML package, and from that package find the SAX package. I know it's kind of crazy, a package inside a package, a nested package if you will. A package has a special directory, or is a directory with a special double underscore in it, double underscore .py file in it. That file defines the attributes and methods of the package. It doesn't need to define anything. It can be an empty file, but it has to exist. If init.py doesn't exist, the directory is just a directory, not a package, and it can't be imported or contain modules or nested packages. Packages provide a way to logically group related modules. So instead of having an XML package with SAX and DOM packages inside, we could have xmlsax.py and xmldom.py. But that would be unwieldy and difficult to manage. This is kind of a tangent, by the way. You can kind of think of packages similar to like Ruby gems or NPM modules, or just modules in general. So let's move on to the example 2 folder and take a look at this file, this 2.xml, or sorry, 2.py, and then the other one that goes with it, 2.xml. We are importing minidom from xml.dom. Minidom is a minimal implementation of the document object model interface. It is intended to be simpler than the full DOM and also significantly smaller. Line number 5 of 2.py is the one line of code that does all the work. This bit right here. Minidom.parse takes one argument, the file name or an open file object, and the complete syntax is actually a lot longer, but this is sufficient. The object returned from minidom dom.parse is a document object, a descendant of the node class. The document object is the root level of a complex tree-like structure of interlocking Python objects that completely represent the XML document you passed to minidom.parse. ToXML, right here on line 8, is a method of the node class, and it prints out the XML that that particular node represents. For the document object, that this prints out the entire XML document. Nodes are like branches in trees, which can be roots to other branches. This is sort of difficult to visualize without a picture, so check this out for reference. A typical tree would look something like this. Circles with values in them are called the nodes. The node at the topmost level is called the root node, and all the nodes are its descendants. There are parent nodes and child nodes. For example, the node with the value of 3 is the parent node of node with value 1. Node of the value 3 is also a parent node of node 6, and so on. These are all parents and children of each other. Remember one thing, which will be very useful as you do computer science things in a tree. At any point, a node can only have one parent node, while for a parent node, there can be any number of child nodes. And then the last term for you here is leaf nodes, which are nodes without any children, which is the 1, 4, 7, and 13 in this example. Now that you know what nodes are and what parent and child nodes are, we can dig deep into parsing the DOM document. The document object always has only one child node, the root element of the XML document. Node class has a first child attribute and a last child attribute. Also, document object.child nodes will give you a Python list of nodes. So take a look at 3.py in the example2 folder, and actually let me show you the outputs here. This is the result of doing 2.py, and this is the result of doing 3.py. So line number 3 of 3.py will give you a list of child nodes. That is the same as line number 5 of 3.py, which will give you the first child of the doc. Remember we said earlier, document objects always have only one child node. You confirm this with the output of doc.childNodes of that list, which contains only one element. Now that we have the same root element of the XML, we can access its descendants in the same way, and you can go like this until you reach leaf nodes. Here we will have text on the leaves. See sample4.py from the example2 folder. After running 4.py, your output will look something like this. You can see that the doc node contains the entire XML document. Doc's first child is the new character after bank and before account. After bank and before account. Now I want you to predict what the third child code should contain. The answer is the third node should contain XML after /account and the opening of a new account. That is another new line character. Similar to this, every node that contains the account XML will have further children. Remember we said text is on the leaves, so until we get text, we have a way to drill down in the tree. Note that the new line character is a text character, not a node object. Check out 5.py in the example2 folder, in which we are drilling until we get the text. In this case, the account username and other details. Pay attention to line 16 in 5.py. We know number node contains only one child because we don't have tags inside number node, and that child is the text itself, so it would be better to use the data attribute instead of toXML to get the original text out of the XML. And I have for you as well this visualization. you can see how the tree has leaves as data, text, and all non-leaf nodes contain some XML tags. So that's all for this one, and I will see you in part 2 of chapter 9.